In class today, we solved a triangle array missing methods. So, just taking a look back at this here, I'll go over the solution with you. We have an array of triangles called triarray that belongs to this class. It's been initialized in the constructor. We don't really know what the triangles are, but we know that they're valid triangles in there. And we know that there's at least one of them. So, the first method said to count how many of the triangles were equilateral. Um, what is a triangle exactly? We kind of have to familiarize ourselves with the class. A triangle is three side lengths, stored as integers called a, b, and c. However, these are private variables. So the second I step out of this class, I can no longer access them. In other words, when I'm writing my code over here and I'm trying to count how many there are, I can't use a, b, or c. What I can use, though, is any of these publicly available methods. And the one that I'm probably most interested in is this one here called is equilateral. This will tell me as a Boolean, true or false, if the triangle is equilateral. Where do I get a triangle from? Right? There's nothing handed to this method, but remember, there's an instance field here called triarray that is an array of triangle objects. In fact, this would be a great opportunity to use an enhanced loop. So we've seen some basic counter methods before. So far, I haven't counted anything. When I'm finished with this, I'll return how many of these special types of triangles I counted. In the middle, I want to access every one of them. So what I could do is I could ask for a triangle from the try array. Other times when we've done enhanced, we may have written int, string, or double here, but this array isn't holding ints or strings or doubles, it's holding triangles. Even though a triangle is three ints, the actual object is encapsulated as a triangle type. So that's the type of object I'm going to request from the array. The array is type triangle. So when I access the array, I ask for a triangle from it. Once I'm handed that triangle that I've called T, I can ask if it is an equilateral triangle. If it is, that will return true. And if that returns true, I will count it as an equilateral triangle. If it doesn't, then I won't count it. All right. This should handle the decision of whether or not these triangles are equilateral. When we look at least area index, the biggest problems I saw today was just kind of understanding that there's some different things going on here. There's some different ways that we could approach this. Some students track to the index. Some students track the actual triangle. Some students track to the area as a double, or some combination of those things. So there's a few things going on. We have at the top an array of references. And those references per se are triangle objects. So we could ask for a triangle from the array. And we're looking for the least area triangle. So maybe I'll call that like least area triangle. That could come to me from the array. Well, now when I access the array, I always have to say like, which one do I want? Do I want 0, index 1? I'll just take the first one. I know there's at least one in there, so that's safe. I won't bother. Anything that comes to me out of the array, okay, is going to be a triangle. What is a triangle? Well, a triangle is a shape, right? And one of the things about these shapes is that they have areas. Now, the areas that we're seeing here today are being expressed as doubles because there might be decimals to them, okay? So since they're doubles, I could create a double. I could call it like least area, okay? And this is not a triangle now. This is a double. Take that triangle that I just mentioned here, least area triangle. But I got to be careful. I saw a few students write things like this today, or maybe they put try array 0 there. And that's not quite right. So you can't give a triangle to a double. Okay, everything's got to be on the same level. So if I wanted to put this value into a double, I'd have to make sure that it is a double. Now, there is a method in the triangle class called getArea, and the return type of that method is double. It uses a square root. Okay, it's got to be a double. And so if you give me that double aspect of the triangle, then I could save it in a double. One more thing going on here. There's also indexes that belong to this array. The indexes are ints. And so if I wanted one of these, I'd have to put it into an int. Maybe I'd call this like least area index. And I'll just maybe put it at 0. So on all three of these, I'm talking about the same thing. I'm talking about the triangle at index 0. But there's different ways that I could refer to that triangle. I could refer to it by its index. It's kind of like if you were in class and I gave you a seat number. I could call you by your name or by your seat number. Okay. And maybe I could call you by your ID number. Like there's different ways I could refer to you. And they're different things. And here they all have to be labeled differently. Indexes are integers. The areas are doubles because they might have decimals. And the objects, they're neither of those things. They're triangles. Now, a triangle is three side lengths. A triangle is three integers, but all that's encapsulated within that object. This is talking about a memory address or reference that takes you to all that stuff. That's what's being held here by this variable. I don't really need all three of these variables, but it's very important to understand that all three of these variables are different things, different types. In fact, a lot of students that I saw write successful answers only used the index in their answer. And I saw a lot of other students who used a double and an int. So they tracked the area and they tracked the index. Ultimately, this problem is asking for the index. So you are going to need to keep track of the index. You don't really need an you don't I shouldn't say you don't probably want an enhanced loop. Since we are tracking indexes, we probably want to work with a loop that runs off of it. Technically, you could start this loop at 1 because we've already considered index 0, but if that's confusing to you, it's okay to start the loop at 0. We will go all the way across the array, okay? And we'll consider every single one. And inside here, we're going to ask a question. Now, even though we're looking to return an index, I don't care which triangle has the smallest index. That's 0. I care which triangle has the smallest area. So what I want to do is I want to take the triangle from the array. Okay, which one? Well, the one at index I, because that gives me eventually every triangle. First, it's the one at index 0, then it's the one at index 1, and then 2. And since my loop goes all the way across, I'm going to give every triangle a chance. When I get that triangle, I need to extract the area from it. I can't compare a triangle to an area. That's like if I compared a student to an ID number or a name to a grade point average. Like, what does that make sense? Who's bigger, Roger or 3.7? What does that mean? Okay. You can't compare people that way. Compare one person's grade point average to another person's grade point average. Compare one person's name to another person's name alphabetically. But I can't compare one person's name versus another person's grade point average. That doesn't make any sense. So if I'm going to make a comparison here between areas, that's ultimately how I'm going to tell who's the smallest, I've got to make sure that I'm looking at areas on both sides. So right now I've got an area versus an area, a double versus a double. That's crucial. Okay. Now, if I'm working this way, one of the problems is it's not just enough for me to keep track of this area. Okay. So yes, I found a smaller triangle and I want to update my area. Okay. That's not quite enough. I'd also have to update this least area index here as well. Okay. Now, when I'm all finished, that index is the one that I'm actually going to return. It's not the area. Notice the return type doesn't say double. Okay, so we don't really need to track the double or the triangle here. We really just need to track the index. Now you might be thinking, well, if I don't track the area, how would I know which one's smaller? Well, there's a way you could do it. Now, for example, if I got rid of this line of code, I'd get an error message because right now I don't have anything called least area triangle. That's okay. I could replace it with try array 0 since that's what it was anyway. And you might be thinking, well, what if he got rid of this code? How would he know which triangle is the smallest? Yeah, that would be tricky because then that means I couldn't use this line of code either. That means that I couldn't use this. So like, how would I do it? Well, Here's how I could. I could actually just go into the array every time, and I could take the one that was at that least, oops, sorry, the one that I'm calling least area index. I could get that particular triangle and get its area. One of the mistakes I saw in virtually every class today was one of the groups wanted to write here something like I plus one or I minus one. That's never going to work. Whenever we're doing minimums and maximums, you never ever want to do side by side comparisons. There's no reason to think that the two smallest triangles have to be next to each other. So if you want to be the best, you've got to beat the best. Maybe you've heard that expression before. It's no different here. If you want to be labeled as the least, you have to be smaller than whatever was previously thought to be the least. It doesn't matter if you're smaller than the triangle next to you. Who cares? What if the smaller triangle came, 1,000 references earlier? What if we have a million triangles? Who cares about side by side triangles? If you want to be labeled as the smallest, you have to like dethrone, beat, oust the previously labeled smallest triangle. So we always want to make sure that we're comparing back to the actual minimum. Never do a side by side comparison. So this answer here is probably about as short as we could make it, 4 lines of code, until the return and make that 5. Okay. Now what's interesting with this answer is we could write a real similar solution down here in our triangle return. So a lot of people were confused by what it meant to return a reference. Well, one of the things we talked about at the start of class is that the array holds references. So when we're ready to make our return, if we return something from the array, it will be a reference to a triangle. How would we choose which triangle to return? Well, if we knew its index, then we could return the triangle found at that index. Do virtually the same thing that you're looking at right here. Okay, now I know that might seem crazy, but let's see. What if we put this here? Now, instead of calling this least area index, I'll call it largest area index. Let me just go through and make a couple changes then. Right. So right here, I'll call this largest area index. Same thing here. Same thing here. Okay. But here's the catch. Uh, I don't want this to be smaller. I want it to be greater. Okay. But right now, I'm returning something labeled as an integer. The return type says triangle. Okay. Well, remember what I said earlier. The array holds triangles. What we just found out where in the array this triangle is. So let's go into the array now. Let's access the array at this index and let's get the triangle from that index and return it. And then that's going to be our triangle return. That's going to be the array holds references. We're now returning a reference from the array. So let's see what happens. Worked on the first time. I can't believe it. Okay. Let's see. It says that looks like I have a three-way tie for the smallest triangle. So we kind of had a couple of choices here. Mine said 0. It could have also returned 3, and it could have also returned 9, but 0 is correct. It says that there were 2 equilaterals. Yeah, I see a 777 here for triangle 1. And what else do we have? We have a 777 here at triangle 8. Okay, so yeah, that's correct. 2 equilaterals. And it says the largest triangle was the one that was a 989 triangle. And that's right here, area 32, and that was a 989 triangle. Yeah, so see, this is perfect. Exactly what we want. There's other ways that you could do this. Okay, this is just a suggestion, and I'll go ahead and share this code with you in the classroom.